Welcome to day 2 of our factoring playlist. Today we are factoring by grouping. So when we're factoring, our first thing to check for is to always check for a GCF. If all of the terms have a GCF, we want to factor that out first. In this case, all of our terms don't have a GCF. My first 3 terms have an n, but negative 10 doesn't have an n, so I can't factor that out. 4, 8, and 10 could all be divided by 2, but negative 5 can't be, so I can't factor out a 2. So I don't have a GCF. There's nothing all of my terms have in common. So I need a different method to try and factor this, and that method is factoring by grouping. Before we get here, I want to look at a multiplication problem first. If I was given this multiplication problem, 2x plus 3 times x minus 6. I know my first step is to distribute the 2x to both terms in my second parentheses. My next step is to distribute 3 into both terms in parentheses. So what I end up with is 2x times x minus 6. That's being distributed. And 3 is being distributed to both terms in parentheses. So these have this x minus 6 in common. So 2x and x minus 6 are both factors here, and 3 and x minus 6 are both factors here. So my 2 terms have a factor in common. They have x minus 6 in common. This is what we're going to be looking for when we're factoring by grouping. We're not going to have something simple we can factor out of every term, like a 2, but we will have a binomial, 2 pieces that can get factored out of each expression. So if we look at our example, 4n plus 4n cubed plus 8n squared minus 5n minus 10. My first step here is going to be to make my terms have a common factor. I need to look at this problem in 2 parts. So I'm going to draw a line down the middle. If I look at my first 2 terms, 4n cubed plus 8n squared, those have a common factor. And if I look at my second 2 terms, negative 5n and negative 10, those have a common factor. So my next step is to factor the GCF out of each group. So in my first group, my common factor would be 4n squared. And if I divide both of these by 4n squared, what I have left over, well, 4 divided by 4 cancels out. N to the 3rd power over n squared is just n. 8n squared divided by 4n squared would leave me with 2. Now when I look at my second group, I have a negative 5n and negative 10. They don't have an n in common to factor out, but I can divide both of these by 5. Actually, because they're both negative, I can divide them both by negative 5. So I'm going to factor a negative 5 out of my second group. Negative 5n divided by negative 5 leaves me with n. Negative 10 divided by negative 5 leaves me with positive 2. So what happened here is that when I factored by grouping, I do have a common factor. My common factor here is n plus 2. Because I have a common factor, I can factor that out of both groups. So if I factor out an n plus 2, well, that means I'm dividing this term by n plus 2. I'm dividing this term by n plus 2. So n plus 2 divided by n plus 2, well, that cancels out. N plus 2 divided by n plus 2, that cancels out. And what I'm left with is 4n squared minus 5. So now my problem is factored. My parentheses, when I pulled out my GCF from each group, ended up being the same. They had the n plus 2. And my final answer gets written as what both my terms had in common. My second set of parentheses is what was left over. So after I divide n plus 2, I'm left with 4n squared and negative 5. Those were my leftovers. To check my answer, I can multiply my binomials back together to make sure I end up with the problem that I started with. So if I'm checking n times 4n squared is 4n to the third power, n times negative 5 is negative 5n, 2 times 4n squared is 8n squared, 2 times negative 5 is negative 10. If I put this answer in standard form, I will see that I have exactly the same problem that I started with. So that means I factored this polynomial correctly. So that checks out. The only other time where things might look a little bit different with these problems, if you flip to the inside, we're going to do this problem on the center bottom. So if I look at all of my terms here, 9c to the third power minus 12c squared plus 18c minus 24. All 4 of my terms have something in common. So my first step is going to be to factor out my GCF. My GCF for these 4 terms is 3. So if I factor out a 3, that means everything's getting divided by 3. I would end up with 3c cubed minus 4c squared plus 6c minus 8. So now my 4 remaining terms, they don't have a common factor between all 4 of them. But if I look at my first 2 terms, these both have c's. That means I could factor out a c. If I look at my second 2 terms, these can both be divided by 2, so I could factor out a 2. So now that I've factored out my GCF, I'm going to factor by grouping. So I'll draw my line down the center. In my first 2 terms, I can factor out a c squared. So that means I am left with 3c to the third power divided by c squared is 3c. Negative 4c squared divided by c squared is negative 4. In my second group, 6c and negative 8, well, those can both be divided by a positive 2. So I'll factor out a positive 2. And when I divide these by 2, I'm left with 6c divided by 2 is 3c. Negative 8 divided by 2 is negative 4. Oh, so I know this was good. This worked out. When I factored out my GCF, I was left with a common factor. 3c minus 4 is my common factor. That means I can factor that out. So if I factor out 3c minus 4, what I have left in this term, once I divide this out, well, those cancel. I'm left with c squared. What I have left in this term, after I divide that out, is a positive 2. So now in my first set of parentheses, 3c and negative 4 don't have a common factor. C squared and positive 2 don't have a common factor. So I know I have factored this completely. So your job is to do the other 8 problems that are on here and then check your answers with the answer key on the board. Make sure you check your answers after every couple of problems so you know if you're doing it correctly.